All right. Hey everyone, Fraser here. I'm the pub user today in the weekly space hangout for Friday, January 23rd, 2015. Joining me this week, we've got Dave
Hey,
Dickinson.
staying warm. Still in northern Maine.
It's really cold there, isn't it?
It's not as bad as it's been the last few weeks. We're actually above 0 Fahrenheit, below 0 for you Celsius. But yes, it's still winter time here.
Awesome. All right, Morgan Rehnberg. Hey Morgan.
Hey, Fraser.
And check this out. Morgan's got a fancy new camera. He's in thrilling high definition.
I feel like those actors who didn't want to be filmed in HD at the dawn of the HD era. All my flaws are coming out.
Oh,
My
we
messy
can tell
bookshelf.
what games you have on your bookshelf with higher resolution. And we've got Dr. Ramin Skibba. Hey,
Hi.
Ramin.
I'm enjoying the nice and cold San Diego.
Oh, don't even start with your fancy weather. Cool. So this week we've got many stories, including new information on the square kilometer array, a quasar that seems to have been caught turning off, a million stories about SpaceX, a huge science release for Rosetta, and some really interesting things you're going to be able to see in the night sky coming up. Plus, cool stories from the Weekly Space Hangout crew. So now, if you want to participate in this conversation and you want to actually give us your comments and ideas, you can click on the Q&A app, which is wherever you're watching this video. You can just click Fraser Cain is interacting with the audience or something, and I should read what that says someday, I think. And then you can click on that, and you can actually see what you can post some comments and questions. And just to witness the power of a fully operational Q&A app, I will say hello to Nancy Graziano, Ronald Minch, Althurian Baltazan, Hugo Burnham, Nathaniel Sanchez, Guido Bibra, Bert Wolters, Stephen Hawkins, not
I
Hawking.
could say not the Stephen Hawking.
Yeah, not the Giselle Sabarin, Tony Lynch. Wow, big crowd. Will Didoni. So one of the best places, and I'm just going to sort of do a shout out right now, one of the best places for you to talk with other huge space fans is to go to the WSH crew, and this is a Google Plus community. I think they're up to like 300-ish members right now, but they are hardcore. So they are, I guess, all of the people who tend to comment on all of our live shows have all found each other, and now they talk to each other, and it's fantastic. And so you could sort of, share your love of space with these people, and they love space as much as you do. More than me. It's quite
Makes
something.
More than me.
Yeah, more than all of us put together. We really are quite impressed. So, cool. Let's get cracking then. So first, I think let's make this the SpaceX show. And this is, I think, Morgan and I were talking about this just before we got started, which is there's so much news coming out of Elon Musk that we could just have our own show, This Week in Musk. And it would just be, what crazy ideas is Elon Musk implementing this week? And it's not just like crazy ideas that he's just saying, but no, he's moving forward. So let's there's three big Elon Musk news stories for sure this week. So Morgan, let's get cracking.
Yeah, so even by his standards, this is a pretty bold idea that he's put forth now, which is that he wants to provide the world with global high-speed internet for a low cost. We're talking high speed, like fiber-fast speed internet, low latency, anywhere you are on planet Earth. And he intends to do that by launching a series of more than 400 satellites using SpaceX to build a satellite internet system that's far more comprehensive than anything that is up there right now. If you have satellite internet today, and you might if you live somewhere that's rural or semi-rural, then you have slow speeds, you have really, really bad latency, and you pay an arm and several legs to get it. With this, he wants to sort of compete with, in the United States, it'd be like Comcast or Time Warner or Verizon, to provide your day-to-day home internet using a series of high-powered satellites.
And this is just like, boy, if you have your own rocket launching company, then that sounds like something that you could pull off.
Yeah, it
Right?
does, doesn't it?
Yeah, and you know how to make these rockets land on their own launch pad and fill them up with more space satellites, more communication satellites, and send them off again. Like it's just, it just absolutely makes sense. But there's more than it just being a communications internet system for Earth. He also wants it to be used on Mars.
Yeah. He's got this notion that he's going to basically colonize Mars single-handedly. And, we all can't live without the internet. And so it's going to be tricky to get people to go live on Mars if they can't check their Facebook from Mars. And so not only will he be deploying this fiber-fast internet to Earth, he's also going to do so, or claims he will do so, around Mars.
Yeah.
Of course, to do this, it's going to take a lot of money.
Yeah, but you pay for that with your Earth-based internet system.
Well, yeah, but even to put up this Earth system, it's going to take a lot of money. And so that was the other big story for SpaceX this week, which is they received a $1 billion investment from Google and the investment firm Fidelity in exchange for a 10% stake in the company. So this values SpaceX as a whole at $10 billion, which is substantial considering what they've accomplished thus far. And it's clear that Google believes that Musk can undertake this global internet idea because Google's really not interested in delivering cargo to the International Space Station. They want people to use Google, and the only way you can use Google is to get online. And so they want as many people to get online as easily as possible. And so it's hard to see this billion-dollar investment as anything other than an endorsement of the notion that we'll soon have a large network of satellites providing internet for us around the globe.
I think this might be SpaceX and Google's greatest legacy, actually, if they pull this off. I think a decade from now, we'll all be like, remember we used to go to hotels and hunt for Wi-Fi codes, and that's all going to be, we're all going to forget about that.
Do you remember do you remember that time when Dave Dickinson was observing in the middle of the desert, and he wasn't able to send us a high fidelity of his?
I'll be telling my grandkids that it's like we can't just beam this stuff out of our brain like we do now. Back then, we always relied on the internet.
Yeah, I've actually had the conversation with my kids already that that you guys will laugh as you see your father scramble from McDonald's to Starbucks searching for open Wi-Fi so he could make a
reservation
for a hotel.
I've done that to finish. I've done that to finish articles. I've scrambled into a McDonald's and ordered coffee just so I could finish an article on their Wi-Fi.
Yeah. So we got two. The third one is the Hyperloop test track.
The third one's a little bit less space-related, but you might remember last year Musk used some engineers from Tesla Motors as well as some engineers from SpaceX to design this sort of futuristic transportation system where we'd all kind of be hamsters in tubes being shuttled from place to place like one might shuttle mail inside of an office to get from, say, Los Angeles to San Francisco, where he originally planned this system, would take just 30 minutes, as opposed to the 4 or 5 hours that it might take when the high-speed rail system opens. Never. But it's gonna cost even more money than this internet satellite system, and so nobody's really jumped on board. So to kind of spur innovation on this, he's decided to build a test track for the Hyperloop, probably in the state of Texas, where universities and companies and other interested parties can bring sort of test cars to the Hyperloop and test how their car performs in the system. And this will push forward, hopefully, the notion that we might actually have a chance of building this high-speed, hopefully efficient way of transporting sort of medium-sized distances.
I think one of the funny things about the way he presented this was he first brought out this idea, back in 2013, I think. And he just said, I've got this great idea, here it is, and then you just listed the tumbleweeds flow by, and he goes, okay, fine, here's all the blueprints. If anyone wants to test this out and make it happen, you've got my blessings. Tumbleweeds, crickets, guy coughing in the audience. So he is going to build it. right? Like, you had your chance. You had your chance to revolutionize long-distance travel and transportation. And now Musk is going to build it because you're too scared. So
He has basically the coolest job in the world.
he really
He also
does.
has a lot of money.
Well, yeah,
Well, but
he uses his money more enjoyably than a lot of other people do, I think.
He's the closest we have to a real-life Tony Stark, basically.
Totally.
So.
But I mean, the thing is when he had started, man, this is just like the Elon Musk love fest, isn't it? When he started, must regain some level of journalistic integrity. When he started, Solar City, Tesla, and SpaceX simultaneously, they all really didn't do well, and he was just on the edge of bankruptcy and could have failed very easily and taken the whole contraption down. So I think we say he's got a lot of money now, but if you go back and you look at stories about Tesla, the stories about SpaceX back in like 2008, it was nonstop ridicule. So there you go. If big ideas, make them happen. So that's all Elon Musk, I think, would want you to do. All right, well, let's move on because as I said, this could be the Elon Musk. This Week in Musk. So Dave Dickinson, let's give people something that they can do with their telescopes.
Yes, coming right up tonight in less than 12 hours, as a matter of fact, there's going to be a rare triple shadow transit on the cloud tops of Jupiter. There's going to be 3 moons transiting at once. Now, it's not too uncommon to see 1 or even 2. There's usually about a dozen double shadow transits a year. We listed them out on our 2015 astronomy article there earlier this January for the better ones for North America. But it's pretty rare to see 3 moons cast shadows at once. You're going to see, starting at 1:26 Eastern Time at 6:26 Universal Time, you're going to see Io, Europa, and Callisto casting shadows simultaneously for 28 minutes. Now, I've seen this twice before. I saw it back in 2013, and I saw it back in, I think it was 2004, back in Arizona. It was 2003 or 2004, back in Arizona. So about once a decade or so. However, if you miss tonight's triple shadow transit, you won't see another one until 2032. Now, Jupiter has 4 bright moons that, they're called the Galilean moons. Luckily, we never called them the Mendician moons, which is what Galileo wanted to name them after his benefactors. Luckily, they got named after him instead, of Io, Europa, Ganymede, and Callisto. However, the question always comes up, can you see a quadruple shadow transit? And the short answer to that is no. Gene Meas, as a matter of fact, calculated from 1980 to 2040, a 60-year span, and there's really only about 9 triple shadow transits that are listed. And the reason has to do with the resonance of the moons. Io, Ganymede, and Europa are in a what's known as the 4-2-1 resonance. Io goes around 4 times for every 1 time that Ganymede, the third furthest out Galilean moon, goes, and Europa goes around twice. And we're not lined up with that resonance point. So you'll always see usually the odd moon out is either Europa or Ganymede. And tonight the odd moon out is going to be Ganymede. It's going to be on the opposite side, while the other 3 are in front facing toward us. They got to be facing toward the sunlit side because the Earth is on that side. So it's kind of neat. I'm hoping somebody's going to do a video animation because, I dug around, and what I've never seen, but the technology's there now with amateur astronomers, is for somebody to do a video animation of these 3 moons crossing in front. I know that Michael Rector's done a lot of these kind of animations before Jupiter. And we're coming right up on opposition, so Jupiter rises right now, right about as the sun sets. So Europe is going to be seeing this at sunset, or at sunrise, and Jupiter set. And here in North America, it's going to be kind of placed right around midnight for most people through central North America, East Coast, right around after 1 a.m. So we're all going to have Jupiter high in the sky in the constellation Leo right now. So this is going to be the last. Unfortunately, it looks like we're going to get snow here in northern Maine, so I'm not going to see this for a 3rd time probably. The Griffith Observatory is going to be streaming this live, however. I just found out earlier today. So that's going to be kind of nifty to watch if you can't get out there and watch this. And I expect tomorrow we may be seeing some animations to this. So last opportunity till 2032, so I would definitely get out there. Interesting fact about the transits of these moons as well. This was one of the first proofs for the speed of light back in the 17th century. It was a Danish astronomer named Ole Romer actually noticed there was a discrepancy observing Jupiter when he's trying to predict these shadow transits when the moons are disappearing and reappearing. And he correctly deduced the reason being is Jupiter was closer and further away. He deduced that the discrepancy was because light was taking time to travel from Jupiter to the Earth. And he made a pretty good stab within a few percent, I believe, estimation, pretty good for the 17th century estimate of the speed of light just using that deduction, looking at those observations. Pretty cool.
That's impressive. That would have to be really, really precise measurement.
And any other observational astronomer at that time might have just figured, either the timing was erroneous. You think of what kind of timepieces they use in, or maybe just thrown that data out. But he correctly deduced that there was something going on there that was cyclical enough that he could identify the actual. There was no reason to suppose then that light traveled at all. I mean, Douglas Adams in Hitchhiker's Guide to the Galaxy says that light travels so fast that it takes most species like millions of years to discover that it travels at all. So,
right.
So there's no reason to suppose, from your day-to-day experience that light takes any travel to time. It's time to travel at all. You would think it's just instantaneous, just from your day-to-day observations.
That's really cool. I've never seen this, so and I won't see it tonight.
Yeah, you're probably clouded out like we are.
Yeah, pretty clouded out.
Watch the feed on Griffith's Observatory. So.
Okay, great. All right, well let's move on. So Ramin, let's talk about the Square Kilometer Array and their.
Yeah, so the Square Kilometer Array, or it's called SCA by most people, which I guess makes you think of music or the brewing company, but there's a lot else going on here. So SCA, the collaboration has just released a whole bunch of papers on the archive. That's ARXIV, where you can find papers, preprints, proceedings available to the public for free. And in fact, these are daily mailings, and so basically Monday and Tuesday I get these emails, and it's SCA this, SCA that, SCA that.
I saw that too. Yeah.
One thing after another, and so it's because they're making plans for this array of telescopes. So there'll be, I think, on the order of hundreds of them, and they'll be in Australia and South Africa. And as you can guess, they have a total collecting area of about a square kilometer. So these are going to be radio telescopes, which they might make you think of ALMA, the Atacama Large Millimeter Array, and LOFAR in Europe. I forget what that stands for. But it's very different in that this array will actually collect data for a very large catalog of galaxies as well as other astronomical objects, and will tell us a lot about cosmology and just about galaxy formation, how they're distributed in the universe. So in fact, that makes it more akin to other surveys, including like Planck and other microwave background telescopes, as well as the upcoming Large Synoptic Survey Telescope in Chile, which is partly funded by the National Science Foundation, and Euclid in Europe. So it's some of the papers that came out on the archive are about synergy with Euclid, synergy with LSST, and so they're thinking about not just their science goals, but how their goals are complementary to those of these other upcoming telescopes.
Yeah, they're turning the world into one big radio telescope.
Basically, yeah, it's pretty amazing. I'd never heard of anything like this before. They're going to observe. Oh, go ahead.
My old observatory in my backyard, I used to call it the very small optical array. So.
Right.
Yeah, that's the kind of that's a typical name that astronomers have, like the very large array and the extremely large telescope. But yeah, so they're going to observe hundreds of millions of galaxies. So right now we have observations of on the order of say 1 million in the relatively nearby universe. But this will give us huge catalogs that we haven't had before. Tell us about how galaxies are distributed. So we use galaxy clustering for that. So there's some statistics we use, as well as what is called weak gravitational lensing, where light coming from a distant object is lensed around a foreground object, and then you see slightly distorted or bent images of galaxies. And if you do this, and if you look at this over a very large volume, which is what SCA will observe, then you can use that as an additional constraint on on how fast the galaxies are moving apart, and also just tell us something about the details of the galaxies themselves. So it looks like a really exciting telescope. I encourage you to look on the archive if you're interested in seeing the nitty-gritty details themselves. But it looks pretty impressive. So I think in the early 2020s is when it's scheduled to get going.
It'd be amazing if we knew a radio astronomer who would be excited to talk about this kind of stuff. But we'll have to have a extragalactic astronomer fill us in on it. So, Nicole, where are you? This is your week. I guess that's the problem. This is her week that she's having to deal with all of this news coming out. But you know, all the stuff. I mean, it was an absolute deluge that came into all of the Astro feeds this week. But the other thing that came deluged in was all of the news on Rosetta, and so we got a huge schwack of news on Rosetta, a whole bunch of science results. So, Morgan, what did you see?
Yeah, so this was just a large raft of papers in the journal Nature detailing many of the early observations of the comet by Rosetta. And these observations will serve sort of as the baseline now for all of the observations we make going forward. It's important to remember that unlike, say, observing a moon of Saturn or even a galaxy, for example, things are going to change on 67P on an almost daily basis over the next couple of years as it approaches the sun and then recedes away from the sun. It's going to start heating up and changing. And so it's important that we watch the same things over and over again to see how changes affect the comet as it approaches the sun. And so a lot of the news that came out was sort of just getting a survey of what's there to begin with. And so one of the things that we found was what the gravity of the comet looks like. And if you remember, the comet looks a lot like a duck. It has this body, it has this neck region, and it has a head. And it turns out that those three regions have very different gravitational pulls, which suggests that they're composed differently. If nothing else, they have different densities. And then we started also taking a look at the surface of the comet to see what's the surface made of, what does it look like, how has it been changed over time. And first off, the surface is really light. It's very light and fluffy, much lighter than the ice that you'd find floating in your glass of water. It looks like this comet was somehow built up kind of layer by layer, alternating some ice, some dust, some ice, some dust, to give this sort of very fluffy arrangement. We also noticed that there's these large pits in the surface that could be a meter to tens of meters across, and they look like these almost perfectly cylindrical pits in the surface, and we're not really sure what might have caused those. Another thing that we observed on the surface that we're not sure what might have caused it was this really long crack in this neck region. So I have a picture here I can share of this crack. And you can see two red arrows here pointing towards this crack that's about a kilometer long and a meter or two across. And this is right in that central neck region. And this is going to help shed light on how did 67P form. There's kind of two dueling ideas. Either it formed as two separate bodies, the head and the body, and then came together and were joined at what became the neck region, or it was one much larger body that has unevenly eroded away over time. And right now we don't have enough information to distinguish between those two possibilities. But as we make more and more observations of the neck, we'll have a better idea of which of those scenarios is most likely. This crack probably formed because of the strange duck-shaped body of the comet. It's going to rotate kind of unevenly. It's going to place stress at the area in which these two segments come together, and that likely helped create this crack. And then one final thing that's kind of puzzling astronomers is some areas of the surface appeared to have sort of like this wavy pattern, like you might imagine seeing, say, in a sand dune. And there's a problem. The waves on a sand dune are caused by wind rippling the sand. There's no atmosphere at the comet, so there can't be wind in the traditional sense. So how did we get this strange rippled pattern? And one idea that's being put forward is that the material that's billowing off of the comet that forms the tail of the comet might be moving rapidly enough and it's dense enough that it could actually push around material on the surface. And that's something that we've never really considered before as a possibility for how comets behave. We always sort of think of these particles streaming right off the surface out into space, never really interacting with the surface. But here seems like possible evidence that those particles push material around, could help even erode the comet, like wind erodes things here on the Earth.
Right, now this is the first time that this comet has been close to the Earth, right? It has an orbit that brings it, or sorry, close to the sun. It has an orbit that brings it close to the sun every, I don't know what the period is.
Right,
But
so it's been going around for millions, perhaps billions of years, and this material streams off the surface, and then it's going to condense back down onto the surface as it cools down again once it passes the sun. And we're seeing it very late in this cycle.
I'm almost imagining gas and dust almost flowing across the surface of the comet like water, or going across a beach. That as it's interacting with the solar wind, it's flowing before it heads off and turns into the tail.
Yeah, that's kind of the picture that some scientists are putting forward, and it seems logical, but that would be a pretty big departure from how we've thought about the mechanics of comet surfaces before. And so we're going to need more evidence before we can really conclude that that's what's happening.
Right. Wow, super fascinating. Any other?
I was just going to say, it actually kind of reminds me a little bit about supernovae in disks of galaxies, where material gets thrown out, but some of it comes back just from the force of gravity, and so you constantly have this ever-changing like disks in galaxies. But this is obviously a much smaller scale, and what's cool about the comet is that it's all moving in the process and is constantly evolving.
And so, oh, go ahead, David.
It's a short period comet. I just wanted to say, I just got to thinking that's the P in 67P, so I looked it up, and it's a 6.4-year orbit, so very short period.
Yeah. Yeah.
Also,
so it's done this thousands, millions of times, right? If it's been around for perhaps billions of years since the formation of the solar system, it's had a chance to go through this process over and over and over and over again.
It must have got captured millions of years ago in the inner solar system, and so interesting though. I think they're talking about the Philae lander might not be dead either, saying that there's a possibility when it gets closer to the sun that it may awaken.
That's the hope, and that was sort of the other big thing here, was that in all of these high-resolution pictures they still haven't found the lander. They were able to see the places where it bounced off the surface, but they haven't found where it's come to rest. And they say that we should find it again if it comes back online in the coming months, perhaps closer to the summer. And even if it doesn't come back alive, they hope to still be able to find it once the illumination from the sun becomes more intense and sort of pushes away some of the shadows that it might be hiding in right now.
That'll be cool if it comes back from the dead. That'd be too cool.
Yeah. Yeah, we'll see what happens. I mean, as you said, again, it's a dynamic, changing environment. Things are going to be happening on the surface that could affect the lander, could affect the orbiter. Stay tuned. This is good. This story's got a lot more legs in it still. But one thing I think that's also really important for people to understand is that we're nearing about 6 months since when, I'm not sure what the exact date was, when they started to take images from with their instruments, and that this is really the first time that we, as the general public, are seeing these high-resolution images. All those pictures that you saw back when they did the landing, when they first arrived at the comet, those were all done with the mission's NavCam system, and not with its really high-quality instrument, the OSIRIS instrument. And so now we're finally seeing these pictures because we've gone through this embargo period that the scientists needed to work on their science data, and now release these images to the public. But the downside of this is that I don't think people are anywhere near as interested now in what they're looking at than they were when the mission was happening and everyone was super exciting. I guarantee that there is less interest going on right now than there was back then. And so I really think that whoever decided on this embargo period really did this mission a big disservice and lost a real opportunity to connect with the public, to make those images available to the public. And here we are. As the publisher of a space news website, and as I look at the traffic and see what level of interest there is in these stories, people are all kind of like, well, Rosetta. Now we're excited about New Horizons. Well, we're going to see the images from New Horizons the second they come out, and same with the stuff from Dawn. So whoever is deciding the policy in Europe, I think they're just making a huge mistake.
I was going to say there was an amazing animation from Dawn this week that came out of series.
Yeah, absolutely. With this wonderful white dot that's a mystery.
Yeah.
This is a great narrative, right? And you've got this amazing white dot that appeared in Hubble's original imagery. Dawn has confirmed it. We don't know what it is. We'll find out when Dawn reaches Ceres, and we're going to actually be able to see it. So,
how do you guys feel? Wrote about that. I almost wrote about that article until I saw Jason jumped on it. But yeah, it's
like Morgan. You're a planetary astronomer. How do you feel about this embargo period?
Yeah, you have to look at it sort of from two sides. One is I'd like to see the coolest stuff as quickly as possible. But on the other hand, I respect the fact that these scientists put a lot of effort into designing these observations. Just taking a picture of a comet is way more difficult than you think. It took lots of people sitting in lots of rooms a lot of times just to take one of those pictures. And if they feel that they need that period of time to sort of make use of that image before allowing others to see it and use it themselves, that's understandable. But it is regrettable that that's sort of the way that the mission has gone. And that's entirely a function of the difference between how NASA operates and how ESA operates. NASA is sort of this centralized entity that controls all aspects of these big missions, and they can make the decision to release Curiosity images or Cassini images or what have you. ESA works a lot more like the European Union. It's basically an agreement between all of these local national space agencies. So you have the French Space Agency and the German Space Agency and the Spanish Space Agency, and they all work together to put together one of these missions. But ESA allows each of those nations to make their own rules regarding the parts that they contribute. And in this case, I think the scientific camera was contributed by Germany. And so Germany, the German Space Agency, sort of over the objection of other people in the European Space Agency, decided that their researchers who use the camera that they designed will have this proprietary period to do that. And I agree that it's really hurt the publicity opportunities that the mission has. And hopefully going forward, ESA will be able to hammer out some sort of centralized agreement about how these kinds of things will be handled.
Yeah.
So just to add to that, both European telescopes, the Planck and Herschel, which were launched together a couple of years ago, they also had similar embargo periods. And we can talk about whether they were done well or not. But you can imagine from the scientist's perspective, there is the issue where you want to make sure that the data products, and that the things you release for the public for outreach are as accurate as possible. And so if you release something early and there turns out to be a major flaw, or you turn out to be very wrong about something, it can not look very good for a project that's been planned over decades. You can make one misstep like that. And another issue that they think about, I don't know how many graduate students are working on projects with this telescope, but there's always a concern that a more senior scientist outside of the collaboration could grab a project which actually was sort of a multi-year project for a graduate student. And so you want to protect projects within the collaboration, but you also don't want to take too long so that people's interests wane. And so it's kind of like a difficult balance, and each collaboration has different priorities, I guess.
I think it's just important for them to remember who's paying for these missions.
Yeah.
Which is the public, right?
I think so one thing I see that's unfortunate is that waiting period gives a lot of ammunition to people that think ESA or NASA are hiding something. And obviously those kind of people are going to think that anyway. But it amazes me the number of people that are staring at all these curiosity photos looking for Bigfoots or flowers on Mars, and it's like, great, we got to write another Pareidolia story again.
Yeah, there was a cat statue found on Mars this week and a gun.
It's almost like a mind is a terrible thing to develop without help. It's kind of like,
Also,
but
did you
there's
hear
people.
that? The international. There was a view of a UFO, and NASA cut the live stream when the UFO.
I heard something.
Came into
I haven't
view.
seen the
Yeah.
image. Yeah. It's probably debris actually from there's probably from the SpaceX launch actually.
Or just anything.
Or military, yeah.
Or the moon, or Venus. I've seen one time where somebody was like, something's following the International Space Station, and we did some of the look at the geometry of the position, and I looked at it, it's like, that's the moon. That's just the moon over the horizon. That's all it is.
It's chasing the space station. So,
Yeah.
anyway, that's my opinion, and fortunately, I'm just a journalist and not in charge of space policy. So, let's move on. So let's talk about. What do I want to talk about? I think I want to talk about an asteroid that's a big, large asteroid that's about to fly right past the Earth.
I think we talked about that last weekend too, but yeah, it's.
But it's going to happen right now.
It is, I think, Monday.
26?
I don't have the. Yeah.
Yeah.
What is it today? Yeah, that's going to be Monday evening, but it's going to reach. What did we say last week? Like 9th magnitude.
Yeah.
It's going to be.
Yeah.
I think what's really cool, and I don't know if I'm going to be able to see this here, but it's going to be going right in front of M44, the Beehive cluster in Cancer. So I fully expect to see some animations of that. That would be kind of neat. And I don't know if the Virtual Telescope's going to be observing that. They usually are. That would be kind of cool to watch it online as well. Somebody's probably going to be streaming it online. But 9th magnitude, that's going to be a binocular object from a dark sky site. And what's cool with these kind of, I seen Asteroid Toutatis a few years ago when it made a close pass. And when you're looking at it through the telescope, you could actually see it moving slightly if you watched it for a few minutes. It's like watching a really slow-moving satellite. So it's kind of cool that we don't usually get to see asteroids moving like that in real time as they're approaching us. So I know Bob King wrote a very good article last week on it, and just seeing it pass in front of M44, that ought to make for a neat little video if somebody's got the capabilities to do that.
All right. Well, Dave has asked for it right now, and we will post your picture. We'll post your animation on Universe Today as soon as you send it to us, everybody.
And hopefully we don't have another large Chelyabinsk incident at the same time. We have
right, of course.
So we're not all scrambling to write stories saying that it wasn't related to the asteroid passing, which everybody will think it was, of course. So.
Yeah. Yeah, so again, that's if you want to do like a Google search for it, it's just search for BL86, and that's the
2014 BL86.
Yeah, 2014 BL86, and that's the designation of the asteroid, and then you can find it. But it's going to be pretty rare, and we're not going to see a big asteroid come this close for quite a while.
It's passing 3 times lunar distances, which usually every year we have a few that pass even closer, but not of the. I believe this is in the 600-meter size.
Yeah, it's about half a kilometer across.
So it's pretty good sized for something that's passing 3 lunar distances from us. So that's a decent pass.
All right, Ramin, let's talk about a black hole a quasar that has turned off. I think you're muted.
Oh, whoops, I was. Sorry. So there were some astronomers at Yale University including Stephanie Lamassa and Meg Urey, who used to be the American Astronomical Society president, actually. They were looking at a particular quasar with the Sloan Digital Sky Survey, and they were looking in what's called Stripe 82, which is this very deeply imaged stripe of the sky, and I think it's near the celestial equator. So they've been able to study a lot of objects, not just quasars, going out to the distant universe and down to faint luminosities and low masses. So they have really detailed information here. And so they found what they call a changing look quasar, where at first it seems to be an object that's very bright, has broad emission lines, and is there's an active nucleus in this galaxy. But then now it seems to be turning off, as if it were a dimmer switch, as they put it, and it's sort of entering another phase. It may be the end of the quasar phase. It's not clear not clear yet, but it looks like these are the sort of periods that can go on and off with a galaxy, and it's important for research about about the evolution of quasars and black holes, but also about how they affect the galaxies that they're sitting in the middle of. So
right, and for people who aren't aware, right, a quasar is the accretion disk around a supermassive black hole, and this is this place where all this matter chokes up, and the black hole can't feed on it fast enough, and it all just kind of, bubbles around the black hole and gets super hot, and you get these jets that will blast out of from these magnetic field lines, and will cross enormous distances, and they'll put out more energy, more brightness than the actual collective energy of the galaxy that they're inside. And
exactly.
they appear early on in the formation of galaxies, and then they shut off. And I guess it's once the galaxy is caught up, once this massive black hole is caught up with all the material that's been falling into it, it shuts back down again. But we've never seen one of these quasars go through one of these phases. And I think I was reading the release that they had seen it go down by about a factor of 7 in brightness.
Yeah, it's as far as I know, as you said, they haven't seen this before. They've seen either objects in that really bright phase where you can catch the light coming out of those jets, or they see sort of you see the before or the after, but never the transition. And so this is pretty cool. And then the question is, how does this affect the galaxy itself? Because when the quasar is giving off light, it may heat up gas in the galaxy and prevent the galaxy from forming new stars. But some people say that that's effect is not strong enough, and maybe it's in a later phase when it has radio emission where that's having a bigger effect. And so it's sort of an ongoing issue that people are working on. And
if this is the case, though, I mean, does this mean that this actual quasar, quasars turning on, is actually it could be a very abrupt process?
Yeah, it could be.
Turning on and turning off.
Yeah, it could be, and it's. I think what would really be nice is to know, what the average time span is for, say, a quasar of some luminosity for being in this phase. And I think, they don't know that yet, but this sort of put some constraint on that. So if they can find more changing look quasars like this, that would be really useful.
Well, and there's some, you mentioned all of those astronomical arrays that are coming out, and one is what the Large Synoptic Survey, right? That's going to be the kind of tool that'll be used for this kind of thing, right? They're going to be taking high-resolution images of the entire sky on a very regular basis, sort of like Sloan Digital Sky Surveys every couple of days. And you're going to be able to then look for those kinds of changing things, asteroids, Kuiper-belt objects, and things like this, where a quasar maybe has changed significantly in brightness, and you'd be able to detect it. So.
Yeah, absolutely. In addition to all the statistical stuff that I was talking about before, you also find rare objects like this. So that's the advantage of having a really huge survey.
Yeah, this is going to be really exciting. Very cool. Okay, so I think we've got some questions here. I highly recommend you go into the Q&A app because there's some useful links in there as well. Nancy Graziano's put in a link to where the live stream of Jupiter is going to be. David, is that what you're running right now, the live stream of Jupiter? No, it looks like his internet has gone bad. Probably he sharing.
NOL. Yeah, and what I wanted to show is real quick is something I've forgotten to mention. You can actually see the difference in the size of each shadow of each moon. The moons aren't all created alike as far as the size of the shadow. Callisto casts a very large shadow, whereas Io, very close in, casts a very small, inky black shadow. So I can actually identify which moon is which by looking at the size of the shadow on Jupiter.
And then you can see the 3 moons there over on the other side of the image. That's just amazing.
Yeah, it's pretty cool.
Yeah.
That's a great picture.
Who did you say was going to stream the transit tonight?
That's the Griffiths Observatory.
Griffiths Observatory. Yeah, I'll check that out.
Yeah. Hugo Burnham tells us LOFAR is the low frequency array for radio astronomy.
Thanks. So I should have remembered that.
Yeah. And Hugo also says that it wasn't ESA's decision; it was the OSIRIS team who decided not to publish the images online. So yeah, that's what we mentioned. It's the OSIRIS, the actual instrument, the really fancy camera and telescope on the mission is called OSIRIS, and it was that team that decided not to post them. Hugo Burnham asks, do we have any idea how long a typical quasar's lifetime is?
I actually don't know. I think it's, I would guess at least 100 million years, probably longer, but I'm not a quasar astronomer, so I'm not going to, so I'm not 100% sure.
Right.
But Meg Urey, who's a co-author on that paper, her expertise is in that, so if you just, look up stuff by her, you will find lots of great information.
Andrew Planet asks, has it been possible to tell if the surface of the comet is soft or hard? If you could walk on the surface of the comet and you had normal gravity, Morgan, do we know if it would be soft and squishy or kind of crunchy? Or?
Well, we know it wouldn't be too soft because Philae didn't sink in too far when it landed. And that's the best direct evidence that we have. But we do also have some more indirect evidence suggesting that the surface is pretty fluffy. Now, we're not talking about like really, really fluffy. It's maybe a fraction as hard as ice, for example. So that's still pretty hard. It's just not as hard as rock would be.
I'm kind of imagining, when it's like you have frost and the ground is all kind of crunchy. That's sort of what I'm imagining. All right, well, let's see. We've got a chance for a couple of stories about that were pulled out of the Weekly Space Hangout crew, and I didn't give the folks any prep on this, so I'm gonna just hit you guys with this and see if you can roll with this one. So the first one is this idea that, I don't know if did we talk about this last week, that there was that the Trans-Neptunian objects suggest there are more planets in the solar system. This comes from Cecil Morgan and Doug Thompson. And I don't know if you guys sort of watched this, but there's a Spanish team that released their research. And what they had done is they had gone through and calculated the position of a whole pile of Trans-Neptunian objects, and based on the gravitational disturbances, inferred that there could very well be a couple of other planets out in the outer solar system. So
it wouldn't be surprising to find out that this was the case, but saying anything definitive would be very challenging, and there's a couple of reasons for that. One is that we've only observed a small fraction of Trans-Neptunian objects. They're very small, they're very, very far away, makes it very challenging to observe them. And so it could well be that there are Trans-Neptunian objects in places that we haven't seen them yet that would make some of the inferences that we do draw off of them somewhat suspect. And the other thing is, it becomes very challenging very quickly to simulate for any length of time the orbits of lots of things in the solar system. And I don't want to cast doubt on the work of these researchers, because I'm sure that they did their due diligence in this. But you have to take into account pretty much all of the other bodies in the solar system to correctly predict the path of any of them. And when you're out that far and we're talking about possible additional planets, even a small change in the size or location of one of those possible planets would propagate very quickly through to the positions of all these other things. And so it's hard to say anything conclusive about, yes, we should look at 50 astronomical units to find a planet the size of Neptune. But it wouldn't be surprising at all to think that there could be some objects out there that we haven't yet found.
Yeah. So this week in Musk, Jim Meeker has contributed a story, and this is just an update. So SpaceX is going to be launching their DSCOVR mission on February 9th. And of course, this was originally supposed to launch a little earlier, and it got pushed back. But this is going to be, in theory, this is going to be the mission that takes another crack at landing on the drone landing pad in the ocean. So, and that's going to be on February 9th. And for those of you who don't know the mission, the DSCOVR, this is this was originally called Triana, and this was Al Gore's dream to build a spacecraft that would view the Earth, the entire Earth, in real time from a Lagrange point. And since then, the spacecraft had sort of been in mothball. I think it had been in like cold nitrogen storage for about 10 years, and it's finally getting launched now. So the actual story and the politics that happen with this are just hilarious, and but fortunately it's been repurposed as well. So it's not just going to be looking at Earth; it's also going to be looking at the Sun and looking for the way energetic particles stream off the Sun, and also some of the the way these things interact with the Earth. So that's going to be on February 9th. What else? Well, let's think about this white spot in Sirius. So one of the in that image, and I I wish we had the animation. There's this great white spot on Sirius that clearly rotates. What is it, Morgan?
I haven't really been following this story, so I'm going to send this one over to David.
David,
it's a transiting moon. I'm just thinking about moons that are, like triple shadow transits. So I'm gonna go out there and go against everything and say it's a moon transiting in front of. Of course, there's no shadow. So
No, and Hubble saw this quite a while.
Yeah, Hubble
ago,
saw the same thing. So.
It would make more sense for it to be ice.
Yeah.
Yeah, a big
ice patch.
ice. Yeah.
It's not out of the realm of possibility that Ceres may have moons that Dawn will discover, though. That would be kind of cool.
Yeah, that would be amazing.
What are they saying is the most likely explanation? Like, I think I saw something about a crater. But I don't know.
No, yeah, I mean, most people are just saying ice is what the thought is.
A crater would be a possibility because you could have what's called coherent backscatter, where certain geometric effects basically act like focusers. And this is something we have to take into account when we study craters on the icy moons, like those around Jupiter or Saturn. And you can actually end up reflecting back more light that comes in to the particular point that you're looking at. The problem with those is it tends to be only for very particular viewing geometries. And so the fact that this thing remains bright as it rotates suggests that that's probably less likely than something physically different on the surface.
Would it be a good place to house a mega laser?
The Death Star hiding among us.
Yeah.
It's the anti-monolith.
We thought it was Mimas, but it's not.
It's cool, though, that there's such a big object in our solar system that we really have no idea what it looks like. Dawn, is going to do as much for understanding Ceres as New Horizons is going to do for understanding Pluto this year. And those are sort of two of the really big classes of objects we just don't know that much about, yet they probably dominate numerically the objects within our solar system.
And Jim Meeker also posted an interesting story about, and this came from a couple of days ago. This is NASA and Microsoft collaboration will allow scientists to work on Mars. So I don't know if you guys have seen this. There's a new technology released by Microsoft. It looks like ski goggles.
Yeah,
and it displays a hologram in front of your eyes that interacts with the real world, and so you see things that are holographic and things that are real sort of mixed in this display. And the technology is apparently pretty magical and sounds
like
great.
Oculus Rift, yeah.
Yeah, and so one of the applications, and this is just them, I'm sure this is them just coming up with some partners to announce, was that the NASA researchers could stand on the surface of Mars and walk around and look at the rocks and go, let's look at this one and let's look at that one, and then get down low and take a look at what the rock would look like, but I mean, come on, it's video games. Come on.
Yeah, this is really just sort of the last in a long series of trying to get context about the things we look at in planetary science. Actually going all the way back to the Apollo mission, the Apollo astronauts took 3D pictures of the surface of the moon so that scientists back on Earth could understand the relative locations of these things. And Spirit, Opportunity, Curiosity at Mars, they all take 3D pictures of the surface as well, so that we can at least try to get a sense of what we're looking at in more than just a flat 2D environment.
Yeah.
Many telescopes for years have had what people call remote observing, where you can see on your screen, what the telescope is seeing, but this technology sounds about like a million times cooler.
Yeah. But I just want it for video games. Come on. That's what this is for. Okay, so let's move on and give people a chance to find out more about our fine panelists. So, Dave Dickinson, where do people find out more about you?
Let's see. I was active this week on Universe Today, of course, Canada.com, and Listosaur, and I'm currently offering up 3 chapters of my own science fiction on my own site, Astro Guys, and you can find more of that at my Amazon store under David Dickinson.
Okay, are you hearing this? Big publishers and movie
any publishers
producers.
take note. And, Ridley Scott or anybody take note out there.
Who would Matt Damon play in one of your stories?
He played the Venetian, of course.
Yeah, right, of course, the Venetian. All right, Morgan Rehnberg, where do people find out more? We don't have your
right.
Twitter feed there in your...
Do I
Oh,
not?
no.
Oh, I do not. That's unfortunate. Well, right after this, you can find me over on the Google Plus Space Community. That's if you go to plus.google.com, you click Communities, choose Space. We can talk about any of the things we talked about today, any other questions or comments you might have, how well you like my my bookshelf. Otherwise, you can pass all that same information along via Twitter, and you can follow me at Morgan Rehnberg. Just take the space out of my name, put an @ in front, and you'll find me.
Yeah, and Morgan needs more followers, so follow him. Follow him. Come on. Ramin, where do we find out more?
So you can find me at Ramin Skibba on Twitter, and my blog website is raminskibba.net. It's called Science Political, and so and in fact today just posted made a blog post about science policy issues and town halls at the American Astronomical Society meeting a few weeks ago. Also, I forgot to mention last week I wrote an article for Universe Today about results from the Baryon Oscillation Spectroscopic Survey, or BOSS, and there'll probably be more coming up. I just have lots of great story ideas coming from the AAS meeting, and so stay tuned.
Right on. Cool, and of course I am at FKain on Twitter. There, and you can follow us on YouTube as well. You can subscribe if you're watching this right now. You can subscribe to this on YouTube, and that way you'll get notifications whenever we do new shows and all the new videos we've been posting. We just uploaded our 147th Guide to Space about why Andromeda is flying towards us. And that one, I don't know, just took off. So lots of people really enjoyed it. It's been I've been answering a lot of questions about this. So although it's old news, I've known about this for half a century. So, but yeah, so check out our YouTube channel. Cool. Well, hey, thanks guys for joining me this week. We may have a special guest next week, but we've got a bunch of special guests. We had so much fun with getting Andy Weir on the show. We've got a whole pile of cool special guests that are going to be coming up. So stay tuned. All right. Well, we'll see you all next week.